Well, hello to everybody who hangs out in buildings, and a special welcome to everybody who's interested in passive house. I'd like to share with you a real-world success story of what happens when you apply high temperatures to a super insulated building. All right, this is it. A little granny flat in a Northern California backyard. It's pretty small, as you can see, but the owners had some really high ambitions for the place. We can talk about some of those in other videos. Right now, I'd like to talk about how they wanted to get to an ultra-low energy use building. It's under construction right now, so you're going to get a behind-the-scenes tour. Come on in. So what's the best way to make a low energy use building? You make sure that the roof and the walls, architects call that the envelope, do a really good job of keeping the outside out. And what's the best way of doing that? Using passive house principles. So you'd think, oh, it's a tiny place in a mild climate, piece of cake. But we were still a little bit nervous about it. We had designed it to have not any air conditioning. We weren't 100% certain that it was going to work. This was also the first time that the construction crew had taken on this kind of project. And finally, we were nervous because it's actually this small. It's kind of counterintuitive, but really small buildings, because of their higher surface to volume ratio, can make it harder to hit passive house targets. Okay, so before I tell you what happened, let's do a deep dive into the details of how we actually built the place. I got a little bag of souvenirs here. So on the outside, we have this corrugated metal siding, and the siding is attached to these pieces, which are called Z-girts. You can see why. And the Z-girts, instead of being attached directly to the side of the building, were put onto these little fiberglass standoffs. Now the fiberglass part of it is kind of important because that means that I don't have really conducting metal going from the outside to my building. And the fact that it's got all this room there means that I could put in 4 inches of this stuff, which is mineral wool insulation. Then we get to this stuff. These are little sheet membranes, sticky stuff. We use the orange stuff on the walls, and we use the red version on the roof. And it is our primary air and water barrier. It turns out that it's just as important to keep the air out of the building as it is to keep the water out. So you want to be really careful about that. And that means use a whole lot of this special tape to seal up all the cracks and the little holes and things that you find. Okay, so there you go. So there's our membrane stuck to the side of plywood, and the plywood is then nailed to some wooden studs, see? And the studs sit on top of wooden sill plates, and we used redwood instead of pressure treated wood, and underneath got stapled these gaskets, and the gaskets stop the wood from being in contact with the concrete of the foundation, and they also stop any air leaks coming through sideways. So we got that going on. And then on the inside, in between the studs, we stuffed it with this wonderful fun stuff. This is sheep's wool insulation. Then we did another passive house trick. On the front of those studs, we put up this furring horizontally, like this. And what that does is it gives a space to put all your electrical and plumbing so that the structure is completely intact and there's more room for insulation inside. And then on the front of that, of course, you end up with your final finish, which in this case, for us, was this walnut veneer plywood. And there's one little place in our hut, because we have this funny little secret dog window, where you can still see that. Before we'd put all the insulation in, a guy came out with some test equipment, a blower door, to actually test how well we'd managed to seal the envelope against air leaks. We were aiming for 0.6 air changes per hour at 50 pascals of pressure and sailed in at 0.45. That's awesome. All right, so here we are with a nice envelope all done up, but we haven't got any of the ventilation system in place. You can see the thermostat there, which is connected to heating panels on the ceiling. And you can see the empty loft there with a couple of tubes sticking out of the wall. They're covered in painter's tape right now, where the ventilation equipment is supposed to go. And then we got hit with a real spell of really hot weather. And look what happened. place was all closed up, even at night when the outside temperatures dropped. And the inside temperature barely budged, even after nearly a week of hot temperatures. There was nothing active going on to cool down the place, and it still stayed comfortable inside. And you know what? It's even harder to take the heat out of the place than it is to add it in, which means that having a summer sweater on your building is going to be really welcome when the weather turns cold. There you have it. Clear, solid proof that air sealing and insulating according to Passive House principles totally rocks. This works, it's awesome, and you want it. And here's why. Up front, you can buy much smaller equipment for the lesser amounts of active heating and cooling that you actually will need in a building like this. Because that equipment is smaller, and because it'll be running less, your operating costs will be less. And because the wooden structure, or whatever other structure you've got going on, is better protected behind the air barriers and all the insulation, there will be less costly repairs down the road. It always works because there's nothing to break. It works in power outages. It works in extreme weather events. That means the whole place is more resilient, and that is a measure of safety. Because the interior is more stable and uniform, the building is more durable. And because there's less demand for energy, the entire grid has less strain put on it. Because there's no weird air currents or hot and cold spots, you can sit anywhere in a building like this and be comfortable. And it's quiet two ways. There's no mechanical system that's going to be clanging and banging all over the place. And the insulation reduces all that outside noise. And finally, you're breathing fresh air straight from the outside. It's not coming in through walls that are filled with dust and mold, or coming in through a crawl space filled with spiders and mildew and maybe even radon gas. Because there's so much less energy demanded from a building like this, there's less pollution coming from power plants. And because the buildings are more durable and people like them more, there's less demolition and waste. Thanks to Laurel Architecture and Canyon Construction for making it happen in this case. Ask for a high-performance building envelope the next time you're building, or remodeling, or buying a place. It's totally worth paying attention to the details. And if you're a building professional, challenge yourself. It's totally doable.